You just
I see.
all right. So a quick recap. Yesterday we learned how do we deal with this. How do we deal with graphing sine and cos, and then how does the different coefficients help us in determining what would be the overall impact to the curve. So I will probably take initial 5 minutes to quickly do a recap of that, and then we'll talk about the unit circle, and then how do we graph 10 functions. So we learned if you have a function like y equals to sine of x, if you have to draw that, what did we do? We just created a x and y table like you do for graphing any a function or equation, and then in case of x we took different values of x, 0, 30, 90, whatever, and then we tried plotting it, and we saw that the sine curve looks like this. Here this is nothing but called the amplitude, and this is called the middle line or the midline, and the sine curve always oscillates between this midline. So if this is the amplitude, the height, this same thing you will see when the curve goes downward also. And then we saw that if we change it to y equals to, let's say 2 sine x, meaning if you multiply this, we put a coefficient here of 2, the amplitude gets doubled. This is what happens. Similarly, we also notice that if you have y equal to sine of 2x, this situation is called vertical stretching of the graph. So you will look at what is the coefficient of the sine function, and then that helps you determine what happens to the amplitude. So this is called vertical stretching. So similarly, if somebody says 1 by 2, then your amplitude becomes half. So that was one observation we had. Hey Chris.
Hi sir.
So right now I'm just doing a recap of what we did yesterday, and then we'll continue with what we're planning to learn today. Okay. Now, another thing that we noticed was if you multiply this x by 2, then what you are doing is you are increasing the frequency, meaning it will take. So here it's 0, it's pi, it is 2 pi. So this is called a period, meaning that the time or the distance from the starting point to it completes one cycle. So it starts from here, goes all the way till here to this point, from where it starts a fresh iteration actually. So this is called the period. Okay. So in this case, hey Vishal. So when you're adding a 2 here, I mean multiplying this angle by 2, what happens is your period decreases, and within 2 pi you will have 2 times of this thing. Similarly, if it becomes sine of x by 2, in that case this period gets doubled, meaning it takes 2 times of what it will take otherwise. So basically whatever you have here, if in general every function, if it's written like x, the period is 2 pi, meaning it takes one complete circle to finish one oscillation of the curve. Here when you have x multiplied by 2, that means this is moving faster, meaning instead of taking 2 pi, it completes one oscillation in 1 pi, and then it goes like this. If you're dividing this by 2, then your period gets double basically. So mathematically how you look at it is your overall the period is 2 pi. If you are multiplying by 2 here, if you are making it 2x, this 2 comes here and then tells you what is your new period. meaning it takes only 1 pi to complete one oscillation. If you are dividing this by 2, that means the same thing comes here, 1 by 2, and this goes up, it becomes 4 pi, meaning one oscillation will take, it's here 0, it's pi, 2 pi, let's say it's 4 pi. So this gets stretched. So basically, in this case, what we are saying is your curve is getting stretched horizontally. So one case is vertical stretching or shrinking, which is by multiplying the coefficient here. Second one is horizontal stretching or shrinking, meaning if you divide, it gets squeezed. It is horizontal shrinking. If you divide, it gets extended. That is called horizontal stretching. Any doubt with respect to this so far? So one last time, okay, so that you guys have no doubt, and then this is fairly straightforward. So any function that you talk about, if you're talking about sine of x, this is your curve, 0, pi, 2 pi, 4 pi, let's say. If it is x, this is your period now. If you make it sine of 2x, that means this period gets divided by this number, whatever it is. So it becomes, your period becomes pi, meaning it will take only 1 pi to complete one oscillation. If you do sine of x by 3, that means this 1 by 3 comes here. So you have 2, it comes 1 by 3 comes here, and it becomes 6 pi. That means this is getting stretched, and then this will complete one oscillation. So meaning it will take 6 pi to come to a point from where it will start the second iteration. So this is the classic case of horizontal stretching. So if you divide, you stretch. If you multiply, you shrink. Is that understanding okay? I mean, are you guys able to follow me? Dhanushri, Chris, Prisha, Vishal, everybody? Okay. Now, so we saw this with the sine x. Now if you talk about cos x, same thing we saw. So in case of sine, it starts from 0 and makes this iteration like this. If you are talking about cos, it starts from here and goes like this. Because cos of 0 is always 1, so that is how it starts from this place. And everything else that we talked about, be multiplying a coefficient, putting a coefficient here or putting a coefficient here, same thing applies here. And you don't have to memorize this. You have to always, whenever you have to graph a function, you just take some angles and then you try plotting it, then you will see. Now there is another scenario that you will come across. Let's say if you say sine x plus 3. What it means is, instead of sine x, if you're talking about sine x, you're starting from 0. If you put a 3, that means your curve moves by 3 points and starts from this place. No, my bad, sorry. If you're saying sine x plus 3, you're always talking with respect to your midline. Your midline, if you're saying plus 3, your midline shifts 3 points and then it starts from here. If you say minus 3, that means originally your midpoint is the x-axis. It shifts by 3 points and then starts from here. So this is the second part, okay? So where you will see how it moves. So net, when it comes to graphing things, this is how you will relate. What do we mean by graphing a trigonometric function? What is the impact of putting a coefficient, and when you add or subtract something, how your midline moves and then your graph gets realigned. Is this part okay? Dhanushri, Sarah, Neil, yeah? Okay. Now, when we were trying to plot this graph yesterday, I could feel that the table that I was trying to draw, because if I have to plot something, I have to, let's say, plot sin x. So obviously I need to know the value of 0 degree, 30 degree, 45 degree, 60 degree, 90 degree and all. But then, not all of us remember this one. So that's why I felt that we should go back to the unit circle one more time and relate, or we should try understanding how does unit circle help you find out the value of these angles. So let's talk about unit circle a little bit, and then we'll go back to plotting a graph for 10 of x. Is that okay? Okay. So when you say unit circle, what do you mean by that? Simply a circle with radius of 1. So here my radius is from here to here is 1. Here to here is 1. Okay. That is how we look at it. Now, what does unit circle help us with? Unit circle is a tool that helps us determine how my value of sine theta or cos theta will change over time, or when your angle keeps on changing. So let's say this is my unit circle. Let's say this is my vertical axis, this is my horizontal axis. Now, if I pick up any point on the unit circle, let's say if I pick this point, this is y-axis, this is x-axis, and here to here it is 1. That's what this is showing us right now. So, okay. So if you guys don't mind, I'll just fix one thing here quickly. The screen keeps on getting locked. Leave it. We'll see. We'll fix it later. All right. Sorry. So this is a unit circle, and we are trying to find out what happens, or how do we determine the different value of sine theta and cos theta for different angles. Let's say if somebody says find out sine of 45 degree, find out sine of 90 degree, find out sine of, let's say, 360 degree, find out sine of 720 degree or 750 degree, let's say. And it will be very difficult for anybody to remember all these angles. However, for some of the commonly used angles, we'll be able to find it out. Now, let's look at how do we get that. Now, if you're talking about 90 degree, we're talking about from here to here, it's 90 degree. If I'm talking about 180 degree, I'm talking about angles along this semicircle that we see. If I'm talking about 360 degree or anything less than 360, I'm talking about this part of the circle. If I'm talking about 750 degree, what I'm talking about is from here to here, one iteration is 360, one more iteration makes it 720, and 30 more, that makes it 750. So as long as we understand, or we are able to find out different angles, small angles like 30 degree, 45 degree, 60 degree, 90 degree, then we'll be able to find it out. Now there's another thing that we have to understand, which will be how my value of sin x and cos x changes when I move from different quadrant, right? But first we have to understand which value is sin x, representing sin x, and which value is representing cos x. So let's come back to the unit circle again. This is my x-axis and this is my y-axis. If I randomly pick up a point here on the perimeter, let's say this point. So there is a x-coordinate and there is a y-coordinate. Does anybody remember what is the value of x and y coordinate of any point on the perimeter when we are looking at a unit circle? Anybody?
Can you repeat what you said?
So this is my unit circle. I picked up a point on the perimeter, okay, this point. And this unit circle is drawn in a coordinate plane. Now, any point that you pick up along the perimeter, what is the x and y coordinate? Because this is the coordinate plane, right? So from here to here, whatever is the value, this is my x coordinate, right? And this from here to here, whatever is the length, that is my y coordinate, right? That is how you represent x and y coordinate in a coordinate plane, correct? So I am saying, with respect to unit circle, how do you find out the value of x and y coordinate for a point on the perimeter of a circle? Okay. So silence means I need to go into the detail. So what I will do is, I will just join this point with this one and say this is my angle theta, let's say. I don't know how much theta is, but I'm saying this is my theta. Now here to here, this is a unit circle, so this is a radius, or I can say this is 1 because this is a unit circle, so every radius is 1. So this is 1. Now this is my y value, y coordinate value, and this is my x coordinate value, correct? Are you with me so far? Now, here, if you recall your SOHCAHTOA knowledge, then let's see, y by 1, what will be y by 1 with respect to this theta? This is side opposite to the angle theta divided by hypotenuse. So y by 1 will be what? Yeah, Chris.
Yes, sir. I was going to say sine.
Sine theta? So that means my y value is sine theta. This y value or the y coordinate value is sine theta. And then same thing, if I look at this x with respect to this theta, so x by 1 will be the same, cos theta. This is a right angle triangle and this is my theta. So x, which is my base, by hypotenuse, that became a cos theta. So that means my x value is cos theta. So here I will not say x and y now. Hereafter I will say my x coordinate is cos theta and my y coordinate is sin theta. Correct? As long as I am relating that with the unit circle. So now regardless of how much your theta value is, now you can make this as your generic formula, generic concept, and you can keep on traversing along this perimeter of the circle and you can find out the x and y value, and that will relate to the theta. Now you pick up this point. What is the x and y coordinate of that guy? Join this. This is your theta. Okay, and you can say here also, for whatever is the theta angle, x coordinate will be cos theta, y coordinate will be sin theta. Is this part okay? You come to this point. Yeah, Chris.
So for any point on the circumference, would it just be cos theta and sin theta?
Exactly. So see, I did not put any caveat here, right? What did I do? I said, okay, one point on the perimeter and what angle it makes. I got that value. Now you will say, if I'm finding this as my generic rule to follow, then how does it matter which quadrant I am in, right? So this is where unit circle helps us. Now if you look at this thing, your x coordinate of any point is nothing but the horizontal distance, yeah? The horizontal distance, horizontal length, the base. Y coordinate of any point is this vertical one. Now you visualize this. When you come to this point, you are in the second quadrant. Your x coordinate will become negative. Yeah? That means, now you can relate that, okay, when my angle becomes more than 90 degree, my x coordinate becomes negative, meaning x coordinate is what? Cos theta. So the cos theta value, see, we'll come to that. If you look at your cos theta value it starts from 1, then goes to 1 by 2, root 3 by 2, then goes to 1 by root 2, then 1 by 2, and then 0. Between 0 and 90. Here it is 0 for the value for 0 degree, and we'll come to that. We'll try proving this also. This is your 30 degree, this is your 45 degree, this is your 60 degree, and this is 90 degree. So cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 is 0. So what's happening is, it starts from 1 and keeps on decreasing. So meaning, your x coordinate value, now if you look at it, your x coordinate is what? Cos theta. Cos theta when 0 is maximum. When 0, meaning this line coincides with this one. This is 1. As soon as your theta keeps on increasing, this line keeps moving away and this length keeps on shrinking. Once you hit 90 degree, your x coordinate becomes 0. That is the case here. Again, cos values, we'll come to that, okay? How those values are derived, that will come to, okay? But here I'm saying, at least from a visual interpretation point of view, your x value is nothing but your cos theta. When theta is 0, meaning this line is coinciding with this line. This is the maximum value. When cos theta keeps on increasing, this line keeps on shrinking. Once you hit 90, it becomes 0. Yeah? And when cos theta goes beyond 90, your x coordinate is increasing but in the negative direction. So it will increase and become maximum in negative, that is minus 1. From 90 to 180. Now when you move from 90 to 270, 180 to 270, again, by this point at 180 degree, your cos theta was maximum in negative, and then that negative value keeps on decreasing, because as you move, your angle increasing, going to 270, your negative minus 1 now starts reducing to a lesser value of negative, and at this point it becomes 0. So cos of 270 will be 0. So basically, what I'm trying to do here is, just by looking at this unit circle, you would be able to figure out how your cos value is changing from 0 to 360. When you go from 0 to 90, your cos value or the x-axis value goes from 1 to 0. From 90 to 180, it increases in the negative direction and goes up to minus 1. When you move from 180 to 270, it further decreases from minus 1 to moves towards 0. At 270 it becomes 0. And then you move from 270 to 360, again it increases from 0 to 1. Yes, Chris.
Sir, how do you memorize the values of these numbers, like cos of 30 degree, cos of 45?
So this is memorized by doing a lot of problems, which I did when I was your age. Now when I'm teaching you, right, I don't just wake up from sleep and come to teach you guys, right? I do a little bit of preparation. I do revision of what I'm going to teach you guys. So that is, now here, these values I have not memorized because I wanted to memorize. I ended up memorizing it by doing it multiple times, and I will also show you guys how these values are derived, so that since I have, when I was learning, I also tried deriving it conceptually, so it has got kind of glued to as part of my memory. Okay, so one of the neurons were powerful enough to hold it with it, right? But it is more with the practice. Okay, so I'll show you guys. It's fairly straightforward. Okay, you will see it when I do it. You will see that there's only 5 numbers that you need to remember. If I pick up sin theta, 0, 30, 45, 60 and 90. If I remember this, that is just enough for me to memorize everything for cos and tan also, at least for these angles. This starts from 0, goes to 1 by 2, 1 by root 2, root 3 by 2 and 1. Cos is just reverse of this. Okay? So that's why that's what I did. I just wrote the same numbers in the reverse order. That's it. But we'll prove this also. Okay. But coming back to this concept part of it, if you look at this unit circle, how it helps you is, it helps you in visualizing how your cos value increases, decreases when you go from one angle and move towards 360 degree. In this range 0 to 90, cos value decreases, from 1 it goes to 0, and in this range it increases but in the negative direction. So 90 to 180, whatever value you get for cos x, it will be negative. When you move from 180 to 270, it will decrease. From 180 it will be maximum negative -1, and it decreases towards, it increases actually and it goes to 0. And when you go to the fourth quadrant, again x value is positive, so that will be positive. And it only helps you relate. So basically, I will tell you what the trick is. Let's say if I talk about cos of 150 degree. What is the value of cos of 150 degree? Cos of 150 degree is, if I look at this, cos of 150 will be 90 plus 60 here. Or I can say will be equal to cos of this angle also. So basically, I can, cos is the x component, right? So I can say cos of 60, this length, or I can say this 30 degree, this is here to here is 90, so if I remove 60 from this is 30 degree. So here also, whether I find this length or this length, both are same. So if I find cos of 30 degree, that will be equal to cos 150 degree, or cos of 60, if I am taking this angle and looking at this side, this is sine of 60, okay, because this is against this side, right, opposite to this angle. So this will be sine of 60 degree, which will be equal to cos of 30. If I look at this angle, this side is cos of 30 degree. If I look at this angle, this side is opposite to the angle, so it will be sine of 60 degree. Both will be the same value. Whatever value I get, I have to look at whether it's a negative direction or positive direction. So it's negative direction, so I will get the value of cos 30 degree and put a negative to it. So cos 30 is root 3 by 2. So my cos of 150 degree, I don't have to look at this part, I can only look at this part and find out the value of based on this angle, and then put a sign because it's in the second quadrant. Did I explain it okay, or got you guys confused? Okay, let's spend 2 more minutes, okay, because this is a very conceptual thing. If you guys don't get it right, you will start hunting for me, okay? So let's say I'm talking about, two situations, cos of 30 degree and cos of, let's say, 120 degree, okay? Fine? 30 will be in this quadrant. You guys agree? So cos of 30 degree will be in this quadrant. We have not determined what the value is. Let's assume cos 30 is root 3 by 2, okay, for now. We'll prove that. So if I say cos 30, you know that, okay, this is the first quadrant. Cos 30 is what? First quadrant, and this is the x part of it. When I look at it from a unit circle point of view, and x value is positive in this quadrant. So whatever value I get from cos 30, if Mr. Birendra Kumar has told you that cos 30 is root 3 by 2, okay, fine, cos 30 is root 3 by 2. So, and this is in the positive direction, so I will just put the value like this. Because you guys trust me as a teacher, so you agreed. Now, cos 120. Cos 120, how do you look at it? Okay, 120 with 90 plus 30. Okay, so this is my 30 degree. And this was 90. Okay, so this total from here to here becomes 120. I don't have to worry about 120 degree, okay? That triangle is not fun. We have to anyway deal with a right angle triangle. So we'll say 90 plus 30. Now I will, if I find out this, and cos of this angle, I'll be fine. Okay? So, okay, cos 120 will be, so 90 plus 30. Now this 30, I have to find out my x value. Now cos 30, this angle if I pick, it will not give me the x part, right? Here if I say cos 30 of this one, it gives me this part. So basically I need the x coordinate because it's always the cos theta is my x component, sine. So if I have to get this part, because that is my x coordinate, right? So I don't have to get cos 30 here in this case. This 30, I have to get this part, this will be my sine of 30 degree. Okay? You have to always remember that if you are trying to find out the cos theta value, you have to look at the x part of it. So 120 was making, going up till here, 90, this part I will just ignore and look at this angle, and I still have to find out the horizontal component of, or the x component of this coordinate plane, along this coordinate plane or on this unit circle. So I have to find out this length, and this length is nothing but it's against this angle. So as long as if I find the sine 30 degree value, that will give me this value. So sine 30 here, we know that, again you have to memorize and you have to trust me. Sine 30 is 1 by 2. So this length is 1 by 2, but this is in the negative direction. So I will say minus 1 by 2, and that becomes my value for cos 120. So what did I do? I have just drawn 120 degree and I found out where it meets. 90 part I ignored, 30 is what I see here. This is my right angle triangle. If I have to find out the horizontal distance, because cos theta always gives me horizontal distance, so I have to find out this length. This length is nothing but, if I am using this angle for my calculation, this is sine of 30 degree. So I got sine of 30 degree, and since this is along the negative x direction, I'll just put a negative here. That gives me the value of cos 30 degree. And I know it might sound little cryptic, but go with your instinct on the visual part of it. Am I confusing you guys, or I'm still making sense? Pick one more. Okay? Let's pick one more. So then you'll be able to at least trust it. Two thumb rules that you have to always rely on. Cos theta is x part of it. Sin theta is the value along the y-axis, regardless of what angle you are dealing with. If I say find out sine of let's say 45 degree. Or 240, let's say. Okay? Sine of 240. You know that, okay. This is my unit circle. 240 will be 90 plus 90 plus 90 plus 90 is 180 plus 60. I'm talking about this point. And since I'm saying sine, what does it mean? I'm talking about the value along the y-axis. Here, this was my origin. So value along the y-axis is this part. I'm talking about this length. Now 90 you have covered here, 90 you have covered here. So this angle is nothing but 60 degree. Look at this right angle triangle in isolation. This is a right angle triangle with 60 degree. You're talking about this length. This length, if you find it out, then that will be your value for the, see, this is cos theta, sin theta, right? This is your x and y component for the unit circle. You are trying to find out the height. This is your y, sin theta is your y component. So whatever value you get from here to here, that is what you need. And it will be the negative direction that you see. But anyways, let's not worry about the negative part of it. Let's look at this as a right angle triangle. This is 60 degree and this length you have to find out. So if this is y, so we know that this is unit circle, y by 1 is sine 60 degree. Okay. So your y, this length is nothing but sine 60 degree. Or sine 60 degree, again I am forcing you guys to believe me, is 1 root 3 by 2. And since this is now, you found the value of y, which is this length, is root 3 by 2, but this is in the negative direction. So this value will be root 3 by 2 minus. What we were trying to find out, sine 240 degree. Sine 240 degree meaning the y coordinate of this value. We found that value, and by traversing this circle, see, if you have to draw an angle with 240 degree and then you have to find it out, there is no triangle that you will be able to draw with 240 degree angle, right? So eventually you have to break it down. So that's what we did. Using the unit circle, we said, okay, fine, this is 90 degree, this is 90 degree, forget about it. Now I have a right angle triangle with 60 degree angle, and as long as I am able to find this length and consider which direction it is in and apply that, I am good. So if you have to deal with this angle, sine 240 degree, cos 240 degree, or let's say anything in the third quadrant, you will just draw this angle and then look at this triangle in isolation. If you are talking about 150 degree, so 90 degree plus 150, 60 degree, 150 degree, okay, this is 60 degree. Now after doing that, ultimately if you are trying to find out sine of 150 degree, then you are talking about the vertical length, meaning this length. How do you find this length from this triangle? So this becomes your base. Forget about whether it's sine or cos. You have to look at this triangle, find out which side you are trying to find out, and against that angle, how do you find that out? Yeah. Did I make a little bit of sense or got you guys more confused? Okay, let's do one thing. Let's quickly look at how do you find out easier ways to derive value of different angles, okay? Like sine 30, sine 45, sine 0. How do you know what technique we can use for memorizing it? And then we will, once we know that those numbers, then we'll pick that information to find out the angle value of larger angles. Okay, so let's say this is sine cos 10, 0, 30, 45, 60 and 90. These are what we are trying to find out. Now let's look at 0 degree. Okay, so basic trigonometry says sine of theta, let's say this is A, this is B and this is C. Okay, sine of theta is the side opposite to that divided by hypotenuse. You agree? Now sine of theta is, what I will do is, I will still use unit circle, only one corner of the unit circle. I'll keep myself confined to this corner, so that makes it a little easy. So this is 1, let's say this is height and this is base, that's what we'll call it. So if this is theta, okay. So my basic understanding of trigonometry says sine of a theta is side opposite to the angle divided by hypotenuse. Everybody agrees? So sine of theta is h divided by 1 here. Yeah? Now here when theta is 0, what is happening? When theta becomes 0, meaning when will theta become 0? When this point is actually coinciding with this horizontal axis, isn't it? Yeah? That is when this angle will become 0, right? See, the angle is reducing. Angle is reducing. When will this angle become 0? When this line and this line coincides. Correct? What will happen when these two lines coincide? Any thoughts? Okay, let me give you a clue. When these two lines coincide or the angle becomes 0, what happens? What happens to your h? H becomes 0, right? when this angle theta becomes 0, meaning this line moves towards the horizontal axis and literally coincides. Your height, this height became 0, isn't it? Yeah? So that means your sine 0 degree equals, when the sine 0 happens, your height became 0. 0 by 1 is nothing but 0. So one corner of the table filled. Yep. Now let's look at 30 degree. For that I'll use a different technique. I have, let's say, an equilateral triangle. This is side, 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 all the same. Okay? And when we are talking about equilateral triangle, I'm talking about this angle being 60 degree, this angle being 60 degree, and this angle also being 60 degree. Yeah? No contradiction here, right? Now, let me do one thing. I'll draw a perpendicular from here onto this side. So let's say this triangle was A, B and C. I dropped a perpendicular from this vertex to this place, and that became, let's say, D. When I drop a perpendicular from here to here, meaning this angle is 90 degree and this angle is also 90 degree. Yeah? Everybody agrees? Now I have two triangles. Triangles ABD and triangle ACD. I am forcing you guys to believe that these two are congruent. Do you think so? They are congruent. When you say the two triangles are congruent, meaning every property of the triangles match. I am saying this triangle and this triangle, which were developed by, or which were created by dropping a perpendicular from here to here. These two are congruent. Essentially, these two are right angle triangles now, since I have dropped a perpendicular here. And I am saying these two triangles are congruent, meaning this perpendicular line is split this equally into two parts. And you will have to say yes, because this, see, now this is a right angle triangle. And the theorem for congruence says RHS for right angle triangles. If it's a right angle triangle, if the hypotenuse match and one of the side match, they are congruent. Meaning, hypotenuse, these two triangles, these are the hypotenuse. Both are matching. So hypotenuse here is AB and hypotenuse here is SAC. Both are matching anyway, because they are part of a earlier equilateral triangle. And then this side is anyways common. So AD is common in both the places. So the theorem of RHS applies and both are congruent. My only intent here to make them congruent was that this angle and this angle will be the same. Both will be 30 degree. This is 30 degree, this is 30 degree. And this side, meaning, and this side will be same, meaning BD will be equal to DC. Yep. So now we have a situation. I'm saying this part is, if the side was S, it is S by 2. This is also S by 2. This is 30 degree, this is 30 degree, and this is right angle triangle. So now look at, let's say, A, B and D. What we have situation is this. This is A, this is B and this is D. This is 90 degree, this is 30 degree and this is 60 degree. Okay? This is S and this is S by 2. Now this is a triangle. If I have to find out sine 30 degree. Sine 30 degree, meaning this angle, this is my angle. Sine 30 degree by Socrates says the side opposite to that divided by hypotenuse. So S by 2 divided by hypotenuse. What does it become? S by 2 into 1 by S. This gone. What did we get? 1 by 2. Sine 30 is 1 by 2. I took an equilateral triangle, dropped a perpendicular from here to here. We split this into two congruent triangles. We saw by RHS it happens. I got this angle is 30 degree, this angle is 30 degree, and this side are equal, meaning this became half of the original side, which is this or this, from the equilateral triangle. So I got this as side by 2, this as the whole side of the earlier equilateral triangle. So taking this, only this, if I just take this green triangle here and look, visualize this as a right angle triangle, this angle is 30, this is 60, this is 90. If I try finding a sine 30 degree, sine 30 is the side opposite to that divided by hypotenuse. So s by 2 divided by s gives me 1 by 2. I have now, to your point, Chris, why I remember this? Because I have tried proving this theorem to you guys 3-4 times, also in the previous class, not only with you guys, even for the junior kids also. So that is how, since I've seen it happening so many times and I've used this enough, so I remember this. Yes, Vishal.
How can you use this for 45 degrees? Like
I'm not using, no. So there's no one formula, there's no silver bullet. We'll come to that, okay? We'll come to that. So this is for 30 degree, I found this value. I can use this for finding for 60 degree now. If you look at this triangle alone, let's see what all things we know. And let's see if I can use this for finding out 60 degree. So this is my half of the triangle that I'm looking at, where this is S and this is S by 2. And this is 30 degree and this is 60 degree and this is 90 degree. Okay, so if I have to find out sine 60 degree, then I have to find out this side's length by hypotenuse. Now this side's length, this is still a right angle triangle. So Pythagorean theorem applies. What Pythagorean theorem says? This square plus this square equal to this square. So let's say this is x. So x square plus s by 2 whole square, that is s square by 4 equal to this s square. Or x square equals to s square minus this. So s square minus s square by 4 will give you 3s square by 4. Okay? So you got x square equals to this. So x becomes s by 2 square root of 3. So let me unlock you guys. Yep. So what did I do? Same triangle. We knew this side is, let's say the length is s and this is s by 2. That's what we proved before. I have to find out this one, because if I have this value, then I can find out sine 60 will be this divided by hypotenuse. This one we don't know. So we applied Pythagorean theorem, which gave me this side's length as root 3 by 2s. So if this side is s, this is root 3 by 2 times s. Now find out sine 60 degree. Sine 60 degree, this is my 60 degree. The side opposite to that divided by hypotenuse. So root will be equal to root 3 by 2 times s divided by s, which will be root 3 by 2 into s multiplied by, it becomes 1 by s. This you can knock off, this becomes your sine 60 degree, root 3 by 2. Yep. Up to this much, okay? Vishal, no complaints? Okay. Now, let's move on. Now, I am tempted to first get the value for sine 90 degree. Okay. If now you come back to the circle. When you go to sine 90 degree, meaning this angle keeps on increasing and comes to a point where it meets this place. At this place, when it's 90 degree, you are literally, this line is coinciding with this guy. So any sine theta is height divided by hypotenuse. So when this guy coincides with this guy, what is your maximum? What is your height? Same as this guy, 1. This became, yes, radius. So it becomes 1 divided by hypotenuse. Your hypotenuse is not changing, that is remaining 1. So 1 by 1. That is how sine 90 is 1. Agreeable or not? Okay. Now only fill that is not filled for sine theta is sine 45 degree. Now sine 45 degree, see, if you have to make a sine 45 degree situation, the only in a right angle triangle, what I will end up doing is, I will end up dealing with two flavors of a triangle together, meaning a right angle triangle and an isosceles triangle. meaning when these two sides are same, okay, then what will happen? There's one property of a triangle that we know. The angles are in the same proportion of the sides or vice versa. Meaning, if the angle is big, the side opposite to that will be big. If angle is small, the side opposite to that will be small. That's why when you look at any triangle, you will see that the side which is the biggest, the angle opposite to that is also the biggest in the triangle. That's why you see hypotenuse is always bigger, because if you're talking about a right angle triangle, this is going to be the biggest angle of the triangle. So we saw that, right? If you have an equilateral triangle, all the sides are same, that's why all angles are same. That is how everything becomes 60 degrees. So sides and angles, there is a proportion among them. That's a property. Now, if you look at this isosceles right angle triangle, meaning a right angle triangle where the other two sides are matching. These two will match, meaning the angles have to match as well. That's the only scenario for this to be isosceles. And that would mean this will be 45 degree and this is 45 degree. Okay? So now you have a isosceles right angle triangle, meaning a triangle which has 90 degree as one of the angles, other two angles are 45 degree, and these two sides are same. So let's say now you come back to this this unit circle. This is your hypotenuse, and this side are same if this is 45 degree. Okay? So this side and this side are same if it is 45 degree. So this will be 45 as well. So what we are talking about is, let's say this side is some value, let's say x. So this will also be x. I'm just from a length point of view, I'm not saying x or y value, okay? If this value, let me not say x, that will get you guys confused. So let's say this is k, then this will also be k. Are you guys following me so far? Okay. Now, what is happening here is, this is my right angle triangle. So one of my uncle named Pythagoras, right? So Pythagoras uncle told all of us that this square plus this square will be hypotenuse square. Thanks to the uncle, we are obedient kids. So we followed him. So that means k square plus this k square is equal to this square, which is nothing but 1 square. So 2k square became 1. K square became 1 by 2. K became 1 by root 2, because square root of 1 gives you 1 anyways. So this became 1 by root 2. So this length became 1 by root 2. This length also will be the same, 1 by root 2. Now come back to the unit circle. What does unit circle say? This is nothing but your, whatever be the angle, this is nothing but your x component, which is cos of theta, and this is nothing but your y component, which is sin of theta. Both are same. And here my theta is 45 degree. So k is my x component when the theta is 45 degree, which is 1 by root 2. So sin theta is 1 by root 2, and cos of 45 degree also 1 by root 2. That. So we fill this row and we fill one part of this row. Now there is something called the theorem of complementary angle. We'll use that for filling this table quickly. Theorem of complementary angle says, sir, you are 5 minutes early. So theorem of complementary angle says sine of theta is equal to cos of 90 degree minus theta. Okay. This is called complementary angle, meaning when these two angles together make 90 degree. Am I calling out the name correctly? Complementary angle? I believe so. Okay. Now, what this means is, if you are saying sine of 30 degree will be equal to what value of cos theta? It will be equal to cos of 90 degree minus 30 degree. That means cos of 60 degree. So if you have found out the value of cos sine 30 degree will be equal to cos of 60 degree. And I am not going to prove that theorem, okay? That's fairly easy peasy, but I will let you guys explore that. If you get struggle anywhere, let me know. But we'll just apply this theorem. So sine of 30 degrees equal to cos of 60 degrees. Blindly you can assume that if you are given sine of 10 degree, that will be equal to cos of 90 minus 10, cos of 80. Sine of 45 degree will be equal to cos of 45, 90 minus 45 is 45. Sine of 20 degree will be equal to cos of 70 degree because sine of 20 degree is equal to cos of 90 minus 20. So always 90 minus that number is what will be your corresponding thing. Okay? Likewise, the reverse of that also works. If you know cos of 10, you can find out sine of 80 as well. So here, same thing will apply. Sine 30 we know that will be equal to cos 60. So that I'll just replace this value. Now, interestingly, if you know sine of 0, that will be equal to cos of 90. 90 degree minus 0, 90 degree. Cos of 0 will be equal to sine of 90. Same. Similarly, cos of 30 will be equal to sine of 60, root 3 by 2. Done. Okay. Now, sine by cos is what gives you 10. So 0 by 1, 0. This by this, 1 by root 3. This by this, 1. This by this, root 3. This by this, infinity. This table got filled. Did I remember the whole thing? No. I just remember the first line because I have proved that multiple times. As long as I remember this sequence, I am able to fill this table very quickly. Does it make sense? Grace, Dhanusri, Rehan, Sarah, Neil, Sravya, Dev, everybody? Okay, Risha. Alright. Now quickly we'll just try finding out one value, okay? And then we'll see if this understanding is okay or not. If I say find out sine of 135 degree. Sine of 135 degree. Look at the unit circles. 135 degree, 90 degrees here. I don't want to care about it. 135. So 90 plus 45. We are talking about a point which makes this angle 45 degree. Now sine, meaning we are talking about the vertical length. We are talking about the y part. We are talking about this. Okay? Or this length. Now you have this this triangle for your reference. Sine of 45 degree, sine of 135 came to a point where we know that okay fine, as long as I find this height, I'm good. I have this triangle. This is 45. So this side will, if I just look at this triangle in isolation, this side will be equal to nothing but cos of 45 degree, which is again 1 by root 2. Only thing I have to be careful about is it positive or negative? This looks positive. This is in the second quadrant where the y value is positive. Sine 135 is 1 by root 2. Done. If somebody says find out sine of 180 plus 45, 225, we are talking about this angle. Look at this height, and this height is in the negative direction. You find this height and put a negative to it. Come on in, sit down. You find this height and you see negative, you're done. So I would want you guys to use this understanding for playing with unit circles. You can sit here, Nika, it's okay. Yeah? And we'll see if this understanding or visualization of the unit circle and how did we derive those values for different sine, cos and tan, theta for commonly used angles. If these two things are together, you should not face much of a problem. And then they are all complementing things, right? The theorem of complementary angles or basic SOHCAHTOA, and how do we relate? All these things put together should make it easy for you guys. Any questions, any doubt, any confusion?